Good morning and good day. Today's lesson focus is going to be on inequalities. So we're moving on from equations and moving into inequalities today. Just to kind of set the scene, the first thing we're going to do is watch a quick brain pop video, just kind of get all the basics out of the way, and then we'll get into what we're going to learn today.
We use inequalities on the boat to figure out whether... Well, it's not really called lobster hunting because we just set traps for them. Too small. Dear Tim and Moby, what is an inequality and how do I make one? From Lily. An inequality is a mathematical expression that shows the relationship between quantities that are not equal. Inequalities use a set of symbols that mean greater than, less than, greater than or equal to, and less than or equal to. There's an easy way to remember these symbols. You can think of an inequality symbol as a hungry, hungry mouth that's always trying to eat the bigger number. We use inequalities on the boat to figure out whether or not our lobsters are big enough. Now, there are rules in lobster fishing. To keep a lobster, its body, the carapace, has to be at least 8.26 centimeters long. The words "at least" tell us that we're dealing with a greater than or equal to relationship. If we call the lobster's measurement x, then x has to be greater than or equal to 8.26 centimeters. That means it can be exactly 8.26 centimeters, or it can be larger. Let's check it. 9 centimeters. 9 centimeters is greater than or equal to 8.26 centimeters, so we can keep this one. Oh, wait a second. This here's a female lobster, and she's got eggs. We have to put her back. Oh, that's not a math thing. That's a lobster fishing thing. Bye-bye. Whoa, what a monster! Not sure you want to handle that guy. This might be a good time to talk about the maximum size. Any lobster we catch has to measure at least 8.26 centimeters. That's the minimum size. But it has to measure less than 12.7 centimeters. If it measures exactly 12.7 centimeters, then it's too big. So this new lobster's length, which we'll call y, has to be greater than or equal to 8.26 centimeters, but less than 12.7 centimeters. 15.5 centimeters, that's greater than 12.7 centimeters. Sorry, Moby, this just isn't your day. Put it back in the water. Whoa, he's got you! Moby? Wow, are you alright? Well, give me your other hand. I'll help pull you into the boat. Oh dear.
All right, so that video again did a great job just kind of real quick setting the stage for what we're going to be going over today. So a couple of notes to put down. Anything that's missing on your paper, make sure that you're writing down. So inequalities are a statement with infinite solutions. So last week when we did equations, there was only one answer that could make that equation true. In an inequality, any number that is greater than or less than that number, or greater than or equal to, or less than or equal to that number, would be a possible solution set. So we have our basic symbols here: greater than, less than, greater than or equal to, and less than or equal to. So remember, if they have the line underneath of them, that means or equal to, and we'll get to what that means mathematically here in just a moment. But the big key to remember is that the alligator, or whatever you learn, crocodile, the Pac-Man, always eats the larger number. And that's going to be important, especially when we're dealing with negatives and when that symbol may not be what it actually means. And we'll get into some of those examples throughout this week. So again, if you have to pause this video at this time to get these notes in there, make sure you do so. So right here, we have inequalities. I'm going to read them out loud, and then we'll say what they should have been. I'll even give you a quick little real world example, and then solution sets are numbers that make that inequality true. So we're going to start here at the top one with the one all filled out. This would be read as x is greater than 15. We could say any number greater than 15, and in a real world example as this would be a student made more than 15 shots. Now, we always want to start with the first number that makes that inequality true. So the first number that makes x is greater than 15 true would be 16. 16 is greater than 15. 17 is greater than 15. 18 is greater than 15. And then I put the infinite sign just to show you that that number would continue in the positive direction infinitely. The next one, we have y is less than 20. So if I wanted to write this in, that's how I would write it in words. In this one, we could say a number less than 20. And then we could say Mr. Archer has less than $20 in his wallet. And again, if I wanted to show a solution set, numbers that make this true, the first number that is less than 20 would be 19. So 19 is less than 20, 18 is less than 20, 17 is less than 20, and you may see three little dots. Again, that's the same thing as an infinity sign. That just means that the numbers continue in this direction. So 16, 15, 14, all the way into negative infinity. So now, next example, we have m is greater than or equal to 7. So again, if I wanted to say this, I could say a number that is greater than or equal to 7. And again, a real world scenario of this might be, I went to Chick-fil-A at least 7 times this month. And then when I want to make my solution set, we set up the brackets and we would just say the first number that makes this true, the first number that is greater than or equal to 7 would be 7 itself. Then I could say 8, then I could say 9, I could say 15, I could say any number that is greater than 15. Or sorry, any number that is greater than 7. And then the last example that I'm going to do with you before you get to some of these that you're going to start trying on your own in a couple of slides, we have A is less than or equal to 40. So a number is less than or equal to 40. Again, a real life scenario of this could be something like I invited 40 or less people to my party. The most that could come to my party is 40, meaning I could have 40. So again, if I wanted to make my solution sets, the first number that is less than or equal to 40 would be 40 itself. And then I could pick any number that is less than 40. So I could say -5, I could say -30. Any number that is less than 40 would be an acceptable answer. So today we're starting off with just the basics. Are you able to read the inequality? Are you able to show like a real world example or be able to take a real world example and change it to an inequality? And then solution sets, 3 or more numbers that make it true. So up here, now we're going to get into just being able to graph a little bit today, and then again working with solution sets. So this first one here on the left hand side, I would read this as x is less than -10. Now, even though I said less than, I want you to think about what the shark or the alligator is eating. The alligator's eating the -10. If -10 is bigger, that means that x has to be smaller. So this is going to be important. I know that -10 is over here on my number line. We would use an open circle. We're going to get into graphs a little bit more tomorrow, but anytime we have just less than, we're going to use an open circle. Now, any number that is to the left of -10 would be considered less than. So if I wanted to come up with a solution set, the first number that is less than -10 is -11, then -12, and then -13. So anytime we say solution sets, you got to have at least 3 numbers. Now, the only thing that's going to change with my graph when I go to x is less than or equal to -10, well, 2 things are going to change. One thing is, tomorrow we're going to learn that this dot right here that I used as an open circle to represent x is less than -10 is going to get filled in. And the only thing that's going to change in my solution set is the first number that is less than or equal to -10 is -10 itself. Then I can say -11, then I can say -12. But if we want the first integer that makes this true, the first integer or the first whole number that makes x is less than or equal to -10 true would be -10 itself. And then again, we can think that less than to the left. So again, if we're looking for less than numbers or a number that's smaller, we are going to the left of that number. Okay, do one more example with you. In this example now, we have x is greater than -2. Or again, if I think about the alligator or the Pac-Man or the crocodile, it's eating the variable x. That means that x is the bigger side. So again, the first one here, we're going to have x is greater than -2. Well, here's -2 on my number line. I need any number that is to the right of it. So now we're thinking greater than to the right. Greater than numbers always go to the right of a number. So the first number that is greater than -2, the first number or integer that is to the right of -2 is -1. Then 0, and then +1, and then all the other positive numbers in the known universe. The only thing that's going to change when I go to do x is greater than or equal to -2, well, again, tomorrow we're going to learn that this dot's going to get filled in, so we're going to have a closed circle. It's still all the numbers to the right, but the first number that makes this true is -2, because -2 is greater than or equal to -2. And then again, I would be looking for numbers to the right, like -1 and 0. So the only thing that's going to change with the or equal to part is that you start at the actual number in the inequality. When there is no line underneath of it, we start at the first number that is either to the left or to the right, that's either less than or greater than. Again, I want you thinking in terms of what's the bigger side. If you know x is the bigger side, you're looking for numbers that are to the right of it. In our other example, if the alligator or the crocodile is eating the number, we're looking for x means that it would be smaller, and we're looking for. Okay, when you get to this slide, what we're going to do is have you try some of these on your own. So I give you a situation on the left-hand side. You're going to write the inequality. X is less than, x is greater than, x is less than or equal to, x is greater than or equal to, and then a solution set would be 3 numbers that make that true. So just like I did on the examples back here on this one, you're going to do the same thing. You just don't have to come up with a real-world scenario. Just write the inequality. Okay, so it's basically I gave you the inequality in words, and you're going to write the inequality and tell me a solution set. So I will show you the first one. The first one says n, a number less than -15. So you can use any variable you want, a number x less than, I think which symbol is my less than symbol, the one that looks like a closed L, and then the number because of the order. It said that a number less than -15. Then I think to myself, well, what would be 3 numbers that are less than -15? The first number to the left or less than -15 would be -16, then -17, and then -18. So I would take the next 2-3 minutes and write out your inequalities and try these ones out. Going over the other 3, the second one here, we have a number that is greater than or equal to -12. So again, I'm going to start off with a variable that represents any number. I think to myself, what's my greater than or equal to symbol? -12. The first number that makes this true, that the first number that is greater than or equal to -12 is -12 itself. The next number that is greater than -12, I'm getting closer to the positive. I'm going to the right, which would be -11. And then you could have said any number that's to the right of that, like -10, or you could have said any positive number, 0, 1, 2, 3, 4, 5. They are all greater than -12. The next one here, we have a number that is greater than -2. So again, a variable greater than -2. No need to put the line underneath because it's just greater than the first integer that is greater than -2, that is to the right of -2, is -1. And then I could say 0, and then I could say +1. And then this very last one, a number less than or equal to -15. This is not the same exact example as the one above. This one says a number, a variable that is less than or equal to, so this needed the line underneath, -15. And since I said or equal to, the first number that makes this true is -15, then I could think, okay, what's the next number that is less than -15? To the left of -15 would be -16, and then -17. So if you messed any of this up, my advice to you is to make sure that you have a number line today. I would just plot some basics like zeros in the middle, hey, -5, and then maybe -10, 5, and then +10, and then just remember, any number that is to the left is less than. any number that is to the right is greater than. So if you get stuck, you may want to use a number line to help you figure out, am I looking for a number that is to the left of a number or that a number that is to the right of a number? Left, less than, right, greater than. So you're going to do these two problems. When you're done these two problems, you're going to raise your hand and I will give you a worksheet that is basically this. So again, you're going to write the inequality out and then you're just going to show three numbers that are true. A number greater than or equal to 15, a variable symbol 15 with three numbers that make that true. And then the second one is a little bit tricky. The order is different. They give you the number, then less than a number. Again, think about what the alligator or the shark is eating. It will make this go a little easier. When you're done, raise your hand and I'll give you the assignment for today.